Hello and welcome back. Today we're going to be talking about graphing rational functions. Our main objective is, well, to graph a rational function. We're going to go through several processes or steps in order to learn how to graph these rational functions. First thing we're going to do is give you several examples of them. Then I'm going to give you a graph and we're going to identify the parts, namely the vertical and horizontal asymptotes. Then we're going to find these vertical and horizontal asymptotes. And then we're going to use the asymptotes to graph the function. On to that first objective, you'll see several examples below of rational functions. I know that's a lot to look at once, but all I want you to notice is that all of our rational functions are fractions. So right here, that's a fraction, that's a fraction. Probably don't have to write this in your notes, just making a point. So you notice they're all fractions, but you might be tempted to say, well, wait, Mr. Mrwennersten, this one right here, f of x equals 3x squared plus 2x plus 1, that isn't a fraction. But guess what? I can divide by 1. So f of x equals 3x squared plus 2x plus 1 is also a rational function. So if you wanted to, you could say that a rational function is a fraction. Y'all, our fractions, all the ones we're going to deal with, our fractions will always have an x in the denominator. Notice that every single one of these, except for this one, has an x in the denominator. So when I start showing you examples, just be prepared. You will always see an x in the bottom or the denominator of a fraction. Okay, now that we've identified that our rational functions, at least for this class, will always be fractions with an x in the denominator, let's take a look at our first example. Here's an example of a rational function, and here's its graph. What I want you to notice from this graph is that, first of all, there are 3 parts, which is kind of weird. Not every rational function will have these 3 separate parts. Sometimes they'll only have 2, sometimes they'll have 1. But what you might notice from this graph is that it flattens out to the left. Notice it gets real flat right there. And it flattens out to the right. If you remember back, we did these a long time ago. These are called our horizontal asymptotes. So let me draw a horizontal line right there. Notice that line is at y equals 0. You don't have to know that right now. All you really need to know is that that is a horizontal asymptote. Okay, so again, the main part of what we're doing right now is I just want you to be able to identify the parts of a rational function's graph. Alright, let's identify maybe any other parts. So great, it flattened out to the left, flattened out to the right. But if you look at it a lot more closely, you might notice that it also flattens out going up and down. Flattens out right here and right here. Perhaps flattens out isn't a great word to use. You could say that it gets vertical and straight up and down at these points. These points, or these lines right here, are called our vertical asymptotes. So we have 2 vertical asymptotes and 1 horizontal asymptote. Alright, let's talk about how to find these vertical asymptotes. So notice again that there were 2 of them. One right here and one right here. Now the way we find these vertical asymptotes is we find the numbers that make the denominator equal to 0. If you look at these asymptotes right here, you'll notice that they are x equals -3 and x equals, notice it's counting by 2, so 2, 4. So our vertical asymptotes are x equals -3 and x equals 4. If you look at the denominator of our fraction, you might see a relationship between the -3 and the 4. Notice that negative 3, x equals positive 4. The reason these create asymptotes is we are not allowed to divide by 0. So if you're graphing this function, graphing it along, once you run into a number such as negative 3 that makes the denominator equal to 0, the graph can't ever touch that point. So it gets really close but never actually touches. So if you want to, you can write down that the vertical asymptote are numbers that make the denominator equal 0. Alright, now that we've identified what a vertical asymptote is, let me give you a couple of examples of equations that we're going to need to find the vertical asymptotes for. If you look at this first equation, let's find the vertical asymptote for it. Again, it's the x values that make the denominator equal to 0. So literally what I'm going to do is I'm going to write 3x minus 12 equals 0, and I'm going to solve for x. Plus 12. 3x equals 12. When I divide both sides by 3, I'm going to get x equals 4. And that is my vertical asymptote for this function. Yeah, if you look at the note below, it says this might require factoring the denominator. So if I look at my second example, if I want to find the vertical asymptotes for this, I have to make the bottom equal 0, factor, then solve. So we're looking for two numbers that multiply to negative 4 but add to negative 3. Those numbers are x minus 4 and x plus 1. Which means my solutions are x equals positive 4 and x equals negative 1. So for the second function, my vertical asymptotes are x equals 4 and x equals negative 1. Okay, you try. Go ahead and pause the video, find the vertical asymptotes for these two examples, and press play when you're ready to see the answers. For the first example, you would have had to factor it, and notice that there was a 4 out front, so we had to use the train story or swing and divide. And we get x squared minus 5x plus 4 equals 0. Find two numbers that multiply to 4 but add to negative 5. They would be x minus 4 and x minus 1. We divide both numbers by 4, the number that we swung over, and we get x minus 1 and 4x minus 1. When you solve those, make both of them equal to 0, you get x equals 1 and x equals 1/4. Second example, 25x squared minus 4. You could have factored that as well. Remember, they were both being squared, so you could do difference of squares, getting you 5x minus 2 and 5x plus 2. And you set both those equal to 0, and you'll solve, getting x equals 2/5 and negative 2/5. Alright, now that we've talked about how to find our vertical asymptotes, let's go on to our fourth and second to last objective, how to find the horizontal asymptotes. Y'all, there are 4 rules, and you're going to have these rules memorized for the test, that help us find these horizontal asymptotes. In order to talk about these rules, we need to first define a word, and that word is degree. Y'all, if the degree, which is the largest exponent, of the numerator, meaning the top, is bigger or greater than the largest exponent or degree of the bottom, the denominator, then something happens. So notice the degree of the top is 5, the degree of the bottom is 3. Then we say there is no horizontal asymptote. So if you were given this problem and they said find the horizontal asymptotes, you would say none, there aren't any, because the degree of the top is 5, the degree of the bottom is 3, so the top's bigger than the bottom. Our second rule is if the degree of the numerator is equal to the degree of the denominator. Notice the largest exponent on top is 3, the largest exponent on bottom is 3, so they are equal. Then our horizontal asymptote is, and it's going to be a little bit trickier than the last one, the leading coefficient of the numerator, don't worry, you don't have to know those words, divided by the leading coefficient of the denominator. Y'all, leading coefficient just means the number that's next to that letter with the largest exponent. So we just take the number next to the x to the third, the largest exponent, over the number next to the largest exponent again. So we get negative 12 over negative 20. Then you reduce your fraction, and you get 3 over 5. Let's go to our last rule. It says that if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. Looking at this example, you might notice that there's no x in the numerator. Y'all, that means that your degree is 0, because it's x to the 0. Or rather, there's no x there at all, so the degree is 0. And also remember that if x has no exponent, then it's understood to be 1. So the top was less than the bottom. And that's it. That's the 3 rules you need to know in order to find horizontal asymptotes. And here's 3 examples. Press pause when you're ready to see the answers. After you've worked them out yourself, please press play. For the first one, you notice that the degree of the top is 2, and the degree of the bottom is 1. So the top's bigger than the bottom, which means there is no horizontal asymptote. In the future, I'm just going to write HA. Alright, let's look at the example down below. The degree of the top was 2, because that's the largest exponent. The degree of the bottom was 2. So they are equal, which means we take the number in front, negative 8, and divide it by the number on bottom, 2. And you get negative 8 over 2, which reduces to negative 4. So a horizontal asymptote for that bottom example was y equals negative 4. Looking at this example to the right, you might have been tempted to say no horizontal asymptote, but I would have encouraged you to be careful, because if you distribute this, you'll end up with, in the end, 2x squared minus 5x minus 3. And you'll notice that the degree of the top and the degree of the bottom are equal. So your horizontal asymptote for this example to the right would have been y equals 6 over 2 or 3. I know that was kind of a tricky one, but just be careful. If your bottom's not distributed, you'll have to distribute it in order to find the degree of the bottom.